Hi, welcome to Educators. In this video, we'll see a binary classification problem. For that, we'll be using IMDb reviews dataset, which contains 50,000 movie reviews. These are split into 25,000 training reviews and 25,000 reviews for testing. First, we need to import this dataset. For that, I'm going to use a helper function. So first, I'm going to import the dataset Keras dot datasets import IMDb. Now here I am going to take a helper function load data to load the data, comma, test is equal to IMDb dot load underscore data, and I am going to restrict my word size to 10,000. Right. Now shift enter. Here we are using our helper function load data to load the data into xtrain, ytrain, xtest and ytest. Now we need to understand the format of the data. For that, I am going to just print what actually the data or how actually the data looks like. So we'll just see one sample data. Now you can see a list of integers. This is actually a review which is already been pre-processed and placed in this dataset IMDb dataset. Okay. So this has been encoded into integers, where each integer represents a specific word in a dictionary. Now, similarly, we'll see what actually your white train contains. So for that, I'm going to take a white train for sample 0. Now shift enter. It is containing 1. What does this 1 talks about? This 1 tells you whether the given review is a positive review or a negative review. 0, if it returns 0, 0 tells it is a negative review, 1 means it is a positive review. Okay, and now we'll see what actually the index number for a particular word. Okay, we'll just test it out. For that, I'll just take word underscore index is equal to imdb dot get underscore word index. This is a helper function available. Word underscore get index is a helper function which gives you the word index, a particular word index. Okay, so print word underscore index is of what? I want to find the word index of hello. Now shift enter. The word index of shift hello is 4822. Okay, if you want, you can also test for the other word. We'll just try it out. We'll see the word index of the, and then you again execute it. We can see the word index for the is 1. Okay, next we'll go for decoding of the reviews. We have seen a review in an integer format. We'll see how to decode the reviews. For that, I'll be writing a function to decode so that whenever needed we can reuse the things. Okay, so word index is equal to dictionary. It is a dictionary, a key value pair, comma key for key comma value in word underscore index dot items. Okay, now we are going to define a function with the name some decode of each review we are interested in decoding. So here I am going to take an empty string text, and here for I in review, text plus is equal to and reverse underscore word index of ith. Now text plus is equal to, okay, I'm just giving a space to make it more clear. So return text. Now shift enter. Okay, it has successfully executed. Right. Now we'll call the function decode to test whether it is able to decode or not. So xtrain of 0th sample. Now if you press enter, you can see the text form of this for these integers, right? Here we have seen previously the word index for the is 1. So wherever 1 present in this list, you can see there in that position the, okay. This is how we can decode the reviews. And also one important point here is all the reviews will not be of same length, okay. For that we need to find out what we need to do is to make all the reviews of similar length. We need to go for padding. First we'll see actually what are the lengths of the existing reviews now, okay. Later we'll see if needed we'll go for padding if they are not of equal length, okay. So show lengths is the function I am using. So here we'll go for print length of x train of 0th sample, okay. Similarly you can also go for print length of x test of 0th sample, okay. One more we can go because we need to see the difference both in both the sets, both in the training set and also in the test set. So I'm going to take one more example to show you. So print length of x underscore test of 1, right? That's it. And now I'll be calling that function show lengths. Now shift enter. You can see here, yes, somewhere I have made a mistake here, print spelling mistake. So go back, print, okay. Now shift enter. You can see the samples or the reviews are of different lengths. The first review in the train set is of length 218, the second review is of length 1. The same way the test, in the test also you can see the first review is of length 68 and the other is of size 260. So all the reviews are of different sizes, okay. So we should make them an equal size. For that we are going to use padding. You can use, you can pad with any of the words or the indices, okay, already existing. Now here I'm interested to pad with the, because it's an article and it will not change any meaning of it, right? So I am going to pad it with the. So for that I am going to check once again the word index of it. Earlier above we have seen, so word index of the is 1. So for to pad I'm going to use pad sequence. I need to import pad sequence from Keras pre-processing sequence. So for that I need from TensorFlow dot Keras dot pre-processing dot sequence import pad underscore sequences. Now we are going to pad the trained data. So is equal to pad underscore sequence of x train comma value is equal to with what value you are going to pad it. For that I am going to use word index of what? Word index of the. So the comma, and where you want to pad, at the beginning or at the end of the review. So for that, padding is equal to, we are going to mention here as a post comma, you are going to specify what should be the actual length of the review. Here I want to consider the actual length of the review as 256, so I have mentioned it as 256. Okay, now here if you go through the same, you need to apply for the test data also. We need to make all the samples of the test data of equal length. So the same thing you need to do for the test data, right? And now you just press Ctrl Enter. You can see pad sequence is not defined here. Actually, it should be plural always. I have given as a singular sequence. Now Shift Enter. Yes, it is executed successfully. Now if you see the lengths of all the things, so show LENGTHS and GTHS, now you should see the difference. Yes, if you see the difference, earlier they are of different size, now they are of equal size. Now they are of equal, now they are of equal size. Next, we'll see for the word embeddings. Okay, create we are going to create a model. Okay, so for that we can use either the word embeddings or we can use one hot vector. Okay, here in this example I am going to use word embeddings. Okay, now for that, from TensorFlow I am going to import a sequential model. So Keras dot models import sequential. Next, from TensorFlow dot Keras, at a time, at the beginning you can import all these layers instead of typing it again and again, but to make you clear understanding I am typing it again and again. So embedding dense global average pooling. Okay, now one dimension I am going to consider. Now here we are done with importing the libraries needed. Now model is equal to sequential, and the first layer is the embedding layer. So I'm going to take embedding of the dimensions we need to mention, comma 16, and the next layer will be the global average pooling layer. That is one dimension, right? The next is a fully connected layer, that is a dense layer with 16 inputs, with the nodes. And here I am going to make use of an activation function, which is, here I am going to use ReLU. Other than ReLU you can use some other function like 10h. Many activation functions are available. It's up to you. And finally an output layer with one node and with one activation function, which is, here I am going to use is sigmoid, right? Yes, I have created a model. Now just shift enter. Yes, successfully created. The next is, we have created a model. Now we need to compile the model. So for that, model dot compile, and here you need to give the loss functions. The loss function here I am going to use is binary cross entropy, and also the optimizer to be used here is Adam optimizer I am going to use, is equal to Adam, and here I am going to use a matrix. It is accuracy. Okay, that's all, and we'll see the summary what it is giving us. Model dot summary. Now here the thing here is the mistake I have made something. Is some spelling mistake here. So now shift enter. Yes, you can see a model is a sequential model, and the embedding layer, global average pooling, one dimensional dense layer. Okay, and the dense output layer, we have seen this. Now we'll see what it is actually. The first layer is an embedding layer. This layer takes the integer encoded vocabulary and looks up the embedding vector for each word index. Okay, for that we are using embedding layer. Then goes is the global average pooling layer, which returns the fixed length output vector for each example by averaging over the sequence dimension. And coming to the third is the fixed length output vector. Okay, it is of size, it is with 16 hidden units, and the last layer is the densely connected with a single output node. And the activation function here we are using is the sigmoid activation function. Okay, think it's clear till here. That is the word embeddings we have used. This is how you can create and train the model. And then we'll go for the validation and then evaluation of the things. Finally we'll go for prediction. Okay, so now we'll see that as I'm going to take x val is equal to x underscore train data, that is we are seeing, and here the samples are 10,000. Okay, 10,000, right. Now we are going to take just the partial x train, so I'm going to take p x train is equal to train, sorry, x underscore train of 10,000, the dimensions I'm going to mention here. Similarly, we'll go for the y. So take y value, the same thing I have copied, just there is a change in one variable, that says y train, and here it is again y train, and here also I'm going to store it and p underscore train, and it will be my y train. Okay, y train. Now shift enter. That's it. Okay, we have it. Now we are going to train the model. Now we'll train the model. We'll train the model for 20 epochs in mini batches of 512 samples. Each size of the batch is 512, and we'll see here how to do that. So history is equal to model dot fit. Now here p underscore x train, comma p underscore y train. These are the inputs I am going to give, comma number of epochs. Here I am going to give for around 20 epochs, and here batch size, as I have mentioned, each of a 512, sorry, 512, and the validation data. What is that validation data? Validation underscore data is equal to, we have mentioned here, right, x value and y value. So take x underscore val, comma y underscore val, and comma we'll go with this should be placed in this. We are going to send two values, so x, now we'll go verbose is equal to 1. Close. Now shift enter. Now your model is getting trained. Okay, with for how many epochs? It is going for 20 epochs, and each epoch, the batch size here we are giving it is 512. Okay, now is going on with some loss, and what is the value loss and what is the value accuracy it is giving. And now we need to, after this we need to evaluate the model. Okay, for that yes, it has completed 20 epochs. So now we'll see we'll evaluate the model. Now coming to this evaluation, I'm going to see the result. So I'm taking the variable as results is equal to model dot evaluate of x test comma y test. Okay, and now we are going to print the results. Shift enter. Now it is getting executed. Now it takes a few seconds to execute. Yes, completed successfully. Now we'll see it is going to return two values. One will be the loss and the other is the accuracy. The accuracy here we are getting is 87.3 and the loss here is 31.0, right? So this is how we can perform binary classification, right? And now we'll see the prediction. We'll give one sample and we'll see whether it is going to give a positive, whether it is going to predict it as a positive or negative. For that, I'm going to import numpy as np. Now prediction is equal to model dot predict np dot expand. I'm going to use this function for x underscore test. For first sample I'm going to take with x is equal to 0. Okay, right. Next I'm going to give class names. If you are not giving this class names here, it will give you either 0 or 1. Okay, so to make it more clear, I'm going to give the class names as text here, just positive or negative. So print class underscore names of, I need to convert int of np dot s squeeze prediction of the 0th sample greater than 0.5. Now here I am just pressing shift enter. Yes, it has successfully predicted it as negative. Okay, the first sample it is going to predict it as negative. The first test sample it is. Okay, the first test sample. In the previous example, in the above code, we have seen the first training sample class and it has returned as 1. Okay, right, which is positive. And here, if you are not mentioning the class names, it could have returned as 0. I hope it is clear. If you like this video, please subscribe to our channel, Educators. Thank you for watching.